Hello, my name is Nathan Perkins. I'm a student with UC San Diego's Embedded Systems program, and I'm going to be showing you how to do basic circuit analysis in LTSpice. If you don't have LTSpice yet, you can get it at this link, or you can search for LTSpice on Google. This is the circuit we're going to be analyzing. We're just going to look at the current and the voltage at different points of this graph. So once you've got LTSpice installed, just click it to bring up this menu and then start with a new blank schematic. You'll notice that there isn't anything really useful in the toolbar. A lot of the functionality is hidden in these menus. So it's really important to learn the hotkeys, which I've listed over here. The first thing we're going to do is draw all of the wires for our circuit. By drawing the wires first, we make it so that we can just place the components over the wires, and then they replace the wire. You don't have to worry about being careful with connecting them. So now that we have the wires, let's set up our first component, which is going to be the voltage source on the side here. And then we're going to use F2 to put in a resistor. We're using Control R to rotate, Control R again to rotate, and now we have all our resistors placed. Now we want to put in a ground, so we get a net name, which is F4, and we use ground. I'll put our ground over here, and then we're going to use F3 and connect it with wires. So now we have our basic circuit set up. We're going to set values for all our components. I'm going to match all of these components are going to be 5 ohms. And this voltage, even though it's not provided, we're just going to say 12. All of this since the analysis we're doing is going to be unitless, we can just kind of shift around the units and see how that affects the system, and use that to derive how all of these things are related. So right now we're not able to actually run the analysis because we need a SPICE directive. So we're going to press S, and then when we right click on this box, we can go to Help Me Edit Analysis command. The values you put in here are not really going to matter because we're just doing a DC analysis. So we can just give it some time values, it doesn't really matter. So then you could put this anywhere you want. And now we should be able to run. Sorry, it needs to run for more than 10 milliseconds. These were backwards. Okay, now we run. We have a graph. It's not really going to be much of a graph because there isn't going to be anything changing about the times, but now we can click on different areas of our graph to find out what the current is and what the voltage is. So if we measure this one, we should see that it's 12 volts. If we should measure this one, well, we can't actually because it's 0 volts and it doesn't allow us to measure it. So the interesting places are going to be across the resistors. So looking at this IB, the current going through this part is actually going to be equal to the current going through this part. And it's going to be equal to the current going through both this and this added together. I0 is going to be only a portion of IB because some of that is going over this line as well. So let's look at these. I'm going to clear this out. So we know this is IB. So we have some amps running across that. And so we know that the currents going across these lines are going to add up to 1.44 amps. So let's see. We put this here, and we see it's 0.5 amps. And we put this here, and we notice that it is about 0.96 amps. So those two add together. And you can tell by the ratios here that just eyeballing it, this one is about 2/3 of the full current going across IB, and this is 1/3 of the current going across IB. If you want to confirm those numbers, you can click here to attach a cursor, and even though dragging it around doesn't do anything, you can actually see the exact numbers that are given here. So this is 960 milliamps, and this is 1.44 amps. So that's all you need to do a basic circuit analysis. Thank you.